So here's a big expression. Kind of ugly too, right? Because it's so big. Now, like we talked about before, sometimes math is just making things be what you want it to be. Well, I don't want this to be this big, okay? So I'm gonna narrow it down so that there's only 3 terms. Why is there only 3? Because there's only 3 types of terms in this math expression. I see I have x terms, which are just terms with just x's. We have a coefficient with x. We have constants, so that's another type of term in this expression. And then we have x squared terms, x to the power of 2 terms. And those are, if you scan through this, you'll see that that's all the types of terms there are. So I want to, well, maybe not want, but I'm going to force this to be 3 separate terms. And I know I cannot combine them because those 3 different types of terms are not like terms. So I do have to keep them separated in the end. And it does say to simplify, but let's identify the terms, okay? So I'm going to start here with the 5x. So I know that I am expecting x terms. So let's list them. All right, so again, just right off the bat there, I've already listed or underlined the 5x. So the 5x is its own term. Now if I scan this, I see I have a 6, it doesn't have an x. So it can't be a, well, I guess I'm listing like terms. You know what, I take that back. I'm just gonna list the terms for now. I'll come back to that listing like terms. So just listing the terms, 5x is its own term, okay? The next one is 6, so I'm gonna separate this with a comma. There's a 6. And again, I'm just scanning this. So next up is 2x squared. So I'm gonna write 2x squared. Next up, I'm scanning. Some students would say this next term is 9, but it's not just a 9. Remember, every term will take the operation to its left as its sign. It's actually a -9 right there. But it's the operation to its left that becomes its sign, whether it's addition or subtraction. Subtraction makes it negative. Next up, I see the next term is -5x squared. Next, I see -12x. Then a +4. Then -5x. Again, I'm just scanning this. And once again, this 5x here is negative because of the minus sign right there. So -5x, next up, we got a 3, and it's positive because of the plus sign, 3x squared. And then a 4. Kind of ran out of space there. Then I see I have a 3x. Then a -8. Then a 2x. And then finally, the one at the tail end there, again, it's positive x squared because of the plus sign. That makes it positive. All right, so we did list all the terms. Now I'm going to go into like terms. But again, we've already identified that there's 3 different types of terms. I have x terms. Then we have constants. Then we also have x squared terms. Now again, the x squared there in green that I've listed, that I'm going to be listing, and then the red x, they are not like terms. They're different types of terms because of the exponent of the green x squared. Let's list them. I'm going to start with all my x terms, okay? So once again, let's go back. We know the 5x is an x term. That's nice. Okay, now I'm going to scan this. 6, nope, it doesn't have an x. The 2x does, but it's an x squared, not a like term. -9, no x. How about -5x squared? Well, it's got the x squared again, so that's no good. How about -12x? You could use this list that you made already, but -12x, yep, that one is just a regular x. So it also goes down as another like term with my x's, so -12x. And you can put a comma between there if you want. Continuing to scan this, I got a +4. And then I have this -5x, which is a like term. Then we got a +3x squared, +4, and yep, another x, +3x. And then -8, and then another like term with the x's, +2x. And then the last term there is an x squared. So that's not a like term because of the exponent. Let's go to constants. So I see my first constant there is a 6. It's good. Scanning, we got 2x squared. Nope, that's not constant. It has the variable. Okay, next up we do have the negative 9 though, which is a constant. It's just a number by itself. Negative 5x squared, no, we use the negative 12x, but then we see this positive 4 right there. So we'll list it as a constant. Then we got a positive 3x squared. Nope, that's not a constant, but the positive 4 is again. We have another positive 4. 3x we used, and then the negative 8 there. Yep, that's also a constant. Then again, we got the x squared at the end. That's not a constant. Now, the rest of these that I have not underlined, I'm trying to keep track of what I've used. They should be the x squareds, right? So let's just double check. Yep, that's a 2x squared, positive, by the way. So I'll list it as my x squareds. Next up, I got a negative 5x squared. Then this positive 3x squared. And then finally, it shows x squared. Just to emphasize the coefficient there is a 1. I'm going to show it. It's a phantom 1, but I'm showing it. All right, so there's my like terms. Now the coefficients here, I'm just going to identify these because it's good practice and it's important for you to know what a coefficient is. So in the future, when I say it, you know what I'm talking about. But it has to be with a letter, right? So I'm going to start with my x's. I see that I have a 5x, then a negative 12x. I'm looking at my red list here. Then I got a negative 5x, then a 3x, then a 2x. These red ones are all the coefficients of the x terms. But now I'll list the next ones in green because I'm looking at my x squared terms. These are still coefficients even though they're being multiplied by an x squared. I have a 2, a negative 5, a 3, and again is where it may be useful to see the 1. It's a 1x squared. So there's my coefficients, all right? So we've identified these, but now it says that we need to simplify. So let's go and do that. Now, usually if I was doing this, I wouldn't list these separately, as fun as that was. I'm going to start with my x terms just because my first term here is an x. And usually I would show it like this. So I'm just going to bring all of my x terms together. And I know they're x's, so I'm going to have an x there ready to go. I'm just going to list the coefficient that goes with it. Now, what I'm going to do as well is I'm going to use the calculator. So I'm going to take this 5, and then I'm going to do minus 12, minus 5, plus 3, plus 2. And that will tell me how many x's I should have in the end here. And when I do that, I get negative 7. So again, if you were to combine all these, you would get negative 7 x's. Now I'm ready to do the constants. So I have a 6 minus 9 plus 4 plus 4 minus 8. And looks like when we do that, we get negative 3 there from the constants. Now, you'll notice when I list this, I'm listing it fairly close to the negative 7x, just so we understand that it is going to create a new expression, a simplified expression. It's still representative of the original expression, it's just smaller because we don't like seeing all that crap. But I'm ready now for my x squareds, right? So again, all my green terms here, I'm ready to combine. These will become my new x squared term. So if I were to look at these x squareds, I got 2 minus 5 plus 3 plus 1. And that would give me a total of 1x squared. So I will show it, it's positive 1x squared, so I'm going to show it as plus 1x squared. Some students, though, they don't like to see that 1. They'd like to make it a phantom 1. It really is up to you. It is exactly the same expression, but this is the one we're looking for right there as a simplified expression. Now, what this also means is that if you wanted to, you could take this expression and break it back up into this stuff if for some reason you wanted to and it was helpful.